Hi, my name is Justin Tyler. Welcome to the Demetrix Rare Access series. Today I'm joined by Rathin Bector, Associate Scientist on the Strand engineering team. Thanks for joining us, Rathin.
Happy to be here.
So Rathin, would you just mind letting us know your background and your current role at Demetrix?
Sure thing. So I've been at Demetrix for 4 years now. Joined Demetrix straight out of my undergrad. I was doing a chemical engineering undergrad at Berkeley. I was actually working in Jay Kiesling's lab in Berkeley on a separate project and looking for jobs after I graduated, and heard about Demetrix and it's starting up and was super excited. Heard that the best minds in synthetic biology were coming and working at this company, and wanted to jump at the opportunity to learn from them, learn from the best. And currently I'm a senior associate scientist in the Strand engineering team here at Demetrix.
Great. And so would you mind just letting us know more about your team and kind of the goals and objectives in Strand engineering?
Sure thing. So the Strand engineering team, as it sounds, the main goal is to engineer strains. We build strains that can meet our production milestones. And so strains that can produce the compounds we want them to produce at scale. And there's several different molecules we work on, and part of the role of the Strand engineering team is to scope out new molecules that we can produce that our business team finds valuable, and see how viable they are to produce using our technology.
Great. And so what goes in the typical design of the strand? Could you walk us through that process and how you guys evaluate your design?
Sure thing. So it can be complicated. Definitely can be very complicated. Different engineers have different approaches. But broadly, you can bucket the approaches into rational strain engineering or metabolic engineering, and more library-based approaches. And so on the rational strain engineering side, or metabolic strain engineering side, what we're doing is thinking about our pathway. So our pathway is taking carbon in on one side and producing a different compound with that carbon. And there's various different steps through the way, through that in the form of enzymes. And so when you're thinking about rational strain engineering, what you're doing is thinking about where your bottlenecks in that pathway arise, and then alleviating those bottlenecks so that your substrate that you are feeding to your strains can be converted to that product that you want. So there's various different ways of doing that. I won't bore you with all the details here. But that's largely how you think about it in a rational strain engineering sense. And then on the library side, you kind of make the strains speak to you rather than telling the strains what to do. You provide them a bunch of options and then find what the strain wants, which DNA the strain wants, in order to produce more of that final compound that you want.
Awesome. So it seems like there's a decent amount of testing, kind of seeing what works and what doesn't, and then kind of continually optimizing.
Yeah, definitely. It's definitely an iterative process. It's like, we call it the design, build, test cycle. Design, build, test, learn, technically, so that we learn from our cycle. And yeah, so it's definitely a lot of iteration. We'll have a production strain that we find interesting, and then we'll iterate on that and try to build an even better production strain that we can hand over to our fermentation team.
Great. And so lastly, what are some of the current and future projects for the Strand engineering team?
Yeah, so our focus really has been on going faster and having a higher throughput. So building strains using software, latest software and automation in order to build faster and better, and as well as increase that diversity of the strains that we can screen. So using libraries in the form of enzyme engineering libraries or other forms of libraries to go wider and increase what we can do in every step.
All right, so thank you for joining us for our next edition of the Rare Access series. My name is Justin, and thanks for joining us, Rathin.
Happy to be here.